Welcome back, everyone. This video is about exceptions and using pattern matching, or at least pattern matching like technique for handling exceptions. Now, before we begin, I would like to highlight one point. You may wonder that during the pure functions, I said no exception handling or no exceptions in pure functions. And if that leads to any kind of confusion that why are we discussing exceptions and so on and so forth, so let me just clarify. Exception handling is a reality, since you have to write your application and it has to deal with exceptions. Remember, the blue area was where we were dealing with the pure functions, and the gray area was where we were dealing with the impure reality, the impure world. So in all likelihood, the gray area or the impure world is where you will handle exceptions. So the purpose of this particular video is not to talk about how to integrate pure and impure world so far exceptions are concerned, but to tell you how to the basics of exception handling. With that, let's start. Now, in the world of F sharp, there are two types of exceptions. If you come from .NET background, you understand that everything which is an exception in .NET is driven from system.exception class. So you have a lot of built-in exceptions that you deal with in C sharp slash .NET, examples being these. And then you can create very F sharp specific exceptions. So how to create F sharp specific exceptions? It's like this. So exception keyword, the name of the type, and what do you want in the name of the data that you wish to hold. So for example, a validation error may be of a string. Validation errors may be multiple strings. So we have a string list or a string array or a string sequence, whatever works for you. And this is a business error of a message, and so it becomes a tuple. A business error is a tuple of code and message. So that's how you create your own exception types. This is not the perfect example of how do you build your own exception types. I'll perhaps discuss it later when we move more towards complete applications. But this is just to give you an idea that how you can create your own exception types. Just like you have the throw word keyword in C sharp, you have raise function in F sharp. So you can raise an error or an exception like this or like this. So these are examples of raising .NET C sharp style exceptions, and these are examples of raising F sharp style exceptions. So system.exception, you can actually use the exception. System.exception has all sorts of constructors. Again, even argument exception has more than one constructor. And this is a validation error. Since it is of string, you provide a string. Since this is a tuple, you provide a tuple. So this is how you raise an exception, okay, which is synonymous for throwing an exception. Now, the try catch, the typical try catch from C++, Java, C sharp world is try within F sharp. And please remember, it's an expression. In other words, when you say try whatever you think that may fail with however you wish to handle the errors, this is an expression. If all goes well within the try block, you can say let x equals to. If all goes well within the try block, and since it's an expression, it should end up with a value. That value comes in x. If try section fails, you are then in the throwing section or the rethrowing section. Okay, so I'll just give you an example. So we have two numbers. Let x equals to 10, let y equals to 20. And pay attention, there are three because we are not rethrowing the exception, or re-raising as it is called in F sharp. What we are saying is that answer equals to this string. We are doing an x over y and using string interpolation to get the answer in the value answer. If it is a divide by zero exception, we are saying sorry, can't divide by zero. And if it, in all likelihood, this condition will never be met, because what can possibly go wrong in this case other than this? So this is your wildcard case. If the entire ladder of exceptions couldn't catch the exception, you can say x, which is exn in F sharp, is type alias for system.exception. So exn is what you will nearly always see. That's another problem with the whole IntelliSense thing in F sharp. So exn is nothing but type alias for system.exception. So you will rarely see system.exception, the whole full name used in F sharp. You will very frequently encounter exn. So don't be confused. It's just exception, system.exception, the papa of everything, which is exception in .NET. Now, what you should pay attention to is that there are three legs through which this expression may result into a value. This is one leg. In this case, this is another leg. In this case, this is another leg. And all these legs are resulting into strings. String 1, string 2, string 3. And that's because this whole thing is an expression. It has to be squeezed down to a value, and that value becomes answer. So if you just say x over y, it will not work, because these two legs are returning strings. So if you roll your mouse over, it says this expression was expected to have type end, but it is resulting into a string. So this is what, it goes back to my previous, when I talked about pattern matching, I kept repeating the same thing over and over. Think in terms of expressions, think in terms of the ability to pipeline things. So if you are throwing an exception, for example, you may say re-raise, ex, then it is fine. Okay, you don't need anything, sorry. Oh, what am I missing here? Exception, re-raise. Sorry, yeah. So re-raise simply, wherever you are, and since you are not using ex, you can use the wildcard, whatnot. So if you are not throwing, because re-throwing or re-raising is an abrupt ending. That's not what we want. We want an outcome of this operation, okay? If you want an outcome of this operation, all the branches should result in value, and because all the branches are resulting into value, they can't have different data types. Otherwise, what's the data type of answer? Okay, so quickly summarizing, let answer, this thing is an expression. The answer of this comes here, as opposed to in C# or in Java or in C++. Try, here comes statements, and here you have statements, and here you have statements. That's not what is happening here. This whole thing, unless you are throwing an exception or raising an exception or re-throwing or re-raising, you are dealing with expressions, and expressions must boil down to a value. And since there are multiple paths, you have to be careful of the values you are dealing with. Now, the with section, which is exception handling, is pattern matching. more or less. So all the tricks that are available for pattern matching are available here also. So this bit is which is used for .NET exceptions, because you are doing a type based match. I understand we have not covered type based pattern matching so far, which we will cover soon. So this is nothing but a type based match. So if you are using F# errors, you will perhaps say validation error str encountered validation error str, whatever. So the F# style errors are dealt as if you are dealing with discriminated union cases. This is your wildcard case, typically the last one in the ladder, and this is for dealing with .NET errors, the C# style errors. Okay, so syntactically, it's not the most elegant, the most pleasing to eyes thing. I have my complaint about this with F#, but who am I to complain? And because this is a pipeline, you can because this is an expression, you can get rid of this and you can pipeline the output. Same thing, nothing fancy. If you understand just two things, this example shouldn't confuse you. Everything is expressions, and because everything is expressions, you can pipeline things. One expression goes to the other stage, that goes to the other stage. So this is stage 1 and this is stage 2. If you throw, raise, rethrow, re-raise, whatever, it's the termination of this function goes to the caller, and you end up with the typical error propagation tactics in C# and C++ or the derivatives. But we don't do that in F#. We don't do that. How we don't do that, how do we handle errors properly is for later discussion, but this is the crux of the matter. Re-raising is what I already talked about, that if you don't want to, so I am just re-raising here. This is a silly example of that what could have possibly gone wrong in this case where I'm just doing an x over y. If this was the case, I said can't divide by 0. But if this happened, I don't know what happened. What could have gone wrong here? So I'm just simply re-raising the exception. So quickly summarizing, in F# you deal with two kinds of errors: the .NET errors, the C# style errors, and the errors the error types, the exception types that you create in F#. This is how you create F# type errors. This is not the perfect way of doing it. This is not the most elegant and most systematic way of defining your types for errors. We will talk about it later. This is how you raise .NET/C# style exceptions. This is how you raise .NET F# style exceptions. The try should result into a value. For all cases of exceptions that you are handling, that should also result into a value. The type of value here, here, here should be same. If for some reason you are re-raising an error, that's a terminal point. The function in question, the function which is called, will do the cleanup, go upward. If that function is doing the error handling, exception handling, that is where the exception will be handling. Otherwise it will go up. That is the basics of exception handling from the C++ days. There are exceptions, and exceptions keep going upward in the stack. When the functions are called, you go downward, and when depending upon how you look at it. And when the exception occurs, you go the other way. So with that, I'll conclude this one. See you in the next one. Bye bye.